We've all seen the movie version of a hacker, a shadowy figure in a dark room, typing furiously to break through complex math. In the real world, that almost never happens. Modern encryption math is so sturdy that a computer guessing randomly would need to work for trillions of years to guess the right combination. Attackers don't waste their time trying. Instead, think of digital security as a heavy steel chain. The math itself is thick, solid metal. It is designed to be indestructible. But an attacker looking at that chain isn't going to hit the steel with a hammer. They are going to trace their finger along every single ring, looking for one made out of cheap plastic. That plastic link is human error. It happens when a developer makes a mistake in how they apply that math, or how they store the secret credentials that grant access to the system. A cryptographic failure happens because the way people built the software left a gap for an attacker to walk through. The math is still solid, but the implementation is broken. A secure online connection acts like an opaque envelope. An unencrypted connection is like an open physical postcard. With outdated data transmission, your information travels like that open postcard. Anyone watching the route can read the back. To stay logged in, your browser attaches a digital VIP wristband to every message, proving you are you. If the message is a postcard, that wristband is sitting right there in the open for anyone to see. An attacker on the same network simply watches the traffic go by. They spot the open postcard, read it, and quietly copy the details of your digital wristband. By wearing that copied wristband, the attacker tricks the website into thinking they are you. They gain full access to your account without touching the encryption or knowing your password. Now let's look at how data is stored. Imagine installing a bank vault door made of 2 feet of solid steel and taping the combination directly to the wall next to it. Modern software is built by teams of developers working together in shared online workspaces. Sometimes these digital workspaces are accidentally left public for the world to see. Occasionally, a developer makes a simple mistake. Instead of keeping passwords separate, they type the secret string directly into the shared blueprint, leaving it glowing right there in the text. Attackers know this happens. They run automated search tools that scan millions of public files every single day, specifically looking for phrases like secret key or password. Finding that hidden text gives the attacker the secret credential. They can bypass the server entirely, download the database, and read the contents on their own computer. Before storing your passwords, companies use a mathematical process called hashing. It works like running a sensitive document through a paper shredder. If a company uses an outdated formula, it's like using an old shredder that cuts the paper into wide strips. It's too easy to piece back together. This chart compares outdated hashing on the left to modern on the right. Attackers rapidly guess billions of combinations per second against weak hashes. Modern methods act like crosscut shredders, slowing the guessing process to a crawl, remaining securely locked. Without that intentional delay, a stolen database of weakly hashed passwords turns into an instant buffet for attackers, exposing everyone's login details in minutes. Consider a real-world case where a major financial server gave out digital identification tags based solely on a user's phone number. The plastic link in this system was a lack of verification. The server never asked for a secondary challenge, like a text message code, to prove the person owned that phone number. Because the tags were based on predictable phone numbers, attackers realized they could easily guess tags belonging to other customers. They sent those guessed numbers back to the server. The system accepted them without question, handing over access to accounts of completely different people. If an online identity isn't tied to an unpredictable mathematical challenge, the verification system is just an illusion. When these human errors slip through, the results affect real people. Personal information leaks onto the internet. Bank accounts are hijacked. Companies face massive fines and lose the trust of the people they serve. There is a simple rule developers and security teams can follow to prevent this. If you can see it without a credential, so can the attacker. Keeping data safe isn't just about using the thickest mathematical locks available. It depends on the humans installing those locks correctly, ensuring data is encrypted as it moves, and never leaving secret credentials in public view. True defense means looking past the steel math and actively hunting for our own fragile errors. Now we know how attackers slip past security to steal data. Next time, we will explore what happens when they go a step further and take command of the server itself in our episode on injection.